that affect us? That only affects us on Monday, right?
We'll see you Tuesday too, so we'll only see you one time.
No, you won't. Right. So we'll only miss one day. Well, wait, no, I won't. Tuesday. Okay, Tuesday. Gotcha. Okay. All right. I will not be here Tuesday. I'll be gone Friday, Monday, Tuesday.
When she's Monday, we'll miss her. Tuesday, we'll miss her. We'll see her Thursday. No, not this Tuesday.
Very complicated. Okay. So we're going to talk just briefly about arc length. I actually almost chose to skip over this, but then I was like, it is kind of, a lot of times you'll see it on your SAT. So I thought maybe we better do it. Okay. You all have your notes up now? Danielle says yes, so we're good. Okay. There we go. Okay, so give me some feedback on your project, your tree measuring height project / test. Was easy? Okay. Kind of fun.
Very
get out and get a little.
Yeah.
Very inconsistent with what?
Results.
Yeah. So why do you think that was? Okay, because of the angle, right? So our measuring techniques we're not able to be very precise with our measuring techniques, right? So another thing I observed was that depending on where you went out, a lot of times the ground was not very level. And you don't even notice it. Like one spot that was in particular that I thought was interesting was over by the goalpost. If you went out from the goalpost towards the school, there was a significant drop in elevation. And it didn't even look like that when you walked up to it. So it depends on what angle you walked up to the object. Sometimes you don't even see that there's quite a drop. And there could be a 2 to 3 foot drop there and you don't even realize it. So that there was a significant difference in heights on that one. Probably the most consistent level ground was the lamppost over by the football field that we did. That had probably the most consistent level ground out of all of the objects that we measured. So that has a big difference also. If you're not actually working with a right angle, right? And then, of course, the tree, one of the challenges there was actually seeing the peak, right? And of course, several of you discovered, I wasn't careful enough with my measurements. So that really, those are some of the real issues there, but it was a good learning experience anyway, just doing it. Okay, so today we're going to talk about what we call arc length. And when we refer to arc length, we're referring to, there's the center, we're referring to this length here. So the arc length of a circle in itself, right, refers to the circumference of the circle. Okay. So one of the reasons that I was almost going to skip this, besides the fact that we're a little short on time, was because you can reason this out just knowing that the circumference of a circle is 2 pi r, or pi times the diameter, right? So that would be the measurement of the arc length of the full circle. So knowing that, you can reason through the arc length of different segments. But this will only take us a very short time, and it will save you in some cases later on. Okay, so the arc length formula looks like this. Okay, S equals R theta. S refers to the actual arc length. Did you guys do this in geometry? Okay. R refers to the radius. Theta refers to the central angle. Okay. So let's just look at a couple examples. Given a central angle of 60 degrees, okay, given a central angle of 60 degrees, so that means this angle right here, and a radius of 8 centimeters, find the length of the intercepted arc. Okay. Again, you can do this by setting up a proportion based on the circumference of the circle. Okay, and I'm going to show you that. Okay, so if we know the circumference of the circumference would be 2 pi r. So the circumference would be 16 pi. Okay, so what you could do, if you couldn't remember the formula, right? So we know that the arc length of the full circle, that's what circumference is 16 pi. That's the arc length of the full circle. And how many degrees are in a full circle? 360. We're trying to find the arc length of just this portion of the circle. So we're going to say x, and that's when we're looking at 60 degrees. So now we just solve for x. So 60 times 16 it's 960 pi equals 360x, right? We cross multiply. So I get 8/3. So we look at x equals 8/3 pi, or approximately, oops, 8.38 centimeters. Okay. So you can solve these problems just setting up a proportion like this using your full circumference. Does everyone understand how we did that?
Do you want us to leave it in the pi or?
You can leave it in the pi, yes. Okay, let's do it using our formula for arc length, right? S equals R theta. Now, in order to use this formula, theta has to be in radians. Okay, this has to be in radians. But we can do that easily enough, right? 60 times, how do we convert it to radians? You guys should be doing this quickly. Pi over 180. Yes, we've got to be quick with this. This is going to be pi over 3 radians. So my arc length, S equals 8 times pi over 3, which equals 8/3 pi centimeters. Okay. S equals R times theta. Again, if you forget that formula when it comes to your SAT, you can reason through it by basically setting up a formula, a part to the whole formula, right? So the whole, you're going to do the whole over the whole equals a part over the part. Some people do it differently. Some people do part over whole and so on. But you set up a proportion, okay? And then you solve the proportion. Questions on that so far? Okay. Let's look at example number 2. If a 100-degree arc of a circle, okay, so we're looking at 100 degrees. So, right, if it was all the way over halfway, it would be 180 degrees. So we're looking at 100 degrees, maybe about like that, right? Whoops. A 100-degree arc of a circle has a length of 9 inches. What is the radius? Okay, so that means we're referring to this angle here as our arc, as our angle. And it has, the arc itself has a length of 9. So now we're trying to find the radius. So what do we do? S equals r theta. So that means r equals s over theta. So what do I do? What do I do? What do I do? In order to use this formula, what do we have to do? Convert it to radians, yeah. So 100 degrees times pi over 180. Let's see, that's going to be 10 over 18 or 5 over 9 pi. So my radius is S, what's S? 9 over 5 over 9 pi, which equals 81 over 5 pi inches. That's our radius. Easy, right? You just have to remember the formula. S equals r theta.
You just times the 9 on the bottom, right?
So you flip and multiply. 9 times 9 over 5. Because the 5 over 9 is in the denominator. You flip and multiply. Okay. Find the angle in radians, then convert to the nearest degree. Okay. So again, S equals r theta, therefore S over r equals theta. Okay, S is 8, r is 5. So our angle in radians is 8 over 5. So if I want to find that in degrees, 8 over 5 times 180 over pi. A little neck in here. 8 times 180 divided by 5 pi. Oops. Okay. So I get 91.67 degrees, and it says to convert to the nearest degree. So we're looking at 92 degrees. So when I did it on my calculator, I did 8 times 180 divided by 5 pi. I put the 5, make sure you put that 5 pi in parentheses so that you don't end up having 8 times 180 divided by 5, and then it takes that and multiplies the answer times pi. Okay, so make just to be extra careful with it. Okay.
Wait, so we do that 8 times 180 in the bottom?
No, that's on the top. 8 times 180 divided by 5 times pi. And the 8 times 180, you don't actually have to put in the parentheses. And the reason is, right, if I had 8 times 180 over 5 pi, right, that's going to give me the same thing as 8 times 180 over 5 pi. That's going to yield me the same result, whether I have the 8 times 180 on all in the numerator or if I bring the 8 off, okay? But so the trick here is making sure that that is in parentheses. Otherwise, it's going to take the 8 times 180 divided by 5, get an answer, and then multiply that by pi. and we don't want to have that happen, okay? Yeah, so if I do that without putting the 5 pi in parentheses, I get 904.78. So you've got to be careful. Make sure you put that 5 pi in parentheses. And hopefully, if you got 904.78, you would recognize that that was wrong, right? Because we know how many degrees are in a circle. We know we have 360 degrees in a circle. So we know we're not looking at 804 degrees, okay? Okay, there is a practice worksheet in your Google Classroom. I want you to do that, and then we'll move on. Okay. Practice worksheet, you're going to do 1 through 8. Let me just make sure that I covered everything on the worksheet. Oh, area. I didn't cover area. I'm sorry. That quick, right? Okay, so we're looking at page 11 of your notes. Felt like I was forgetting something. Okay, so here we have a formula for the area of a sector. Right, so what we mean by sector is if we look at our circle, right, we know how to calculate the area of a circle, that's pi r squared. But if I'm looking for the area of just a sector, again, this can be done by setting up a proportion. Right? You could calculate the area of the entire circle with a given radius and compare that to the sector. So you could set it up as a proportion, but if you know this formula, it's a whole lot quicker and easier. So for instance, find the area of the sector of a circle with radius 2 feet formed by an angle of 50 degrees, okay? Again, the angle is supposed to be in radians, so the first thing we're going to do is, well, actually, let me show you how to do this without the special formula, all right? So the area of the full circle, area equals pi r squared. So the area of the full circle will be pi times 4, or 4 pi. Right? So the area of the full circle, 4 pi, and the number of degrees in a full circle is what? 360. So what would that be in radians? 2 pi. 2 pi radians in a full circle, all right? Okay, that equals, now we're looking for the area of the sector over the degrees. So I have to convert the 50 degrees to radians. So we multiply by pi over 180. So that's 5 over 18 pi. 5 over 18 pi. All right. You could work in degrees also in this, using this method. So we're going to do 4 pi times 5 over 18 pi equals 2 pi a. So let's see, we're going to get 20 over 18 pi squared equals 2 pi a. We're going to divide by 2 pi. 20 over 18 pi squared divided by 2 pi. Okay, so 20 over 18 divided by 2. That comes out to 5 over 9. So we get 5 over 9. Now I've got pi squared over pi. So what does that equal? Pi. And this is feet. So there's the area of my sector. Okay. You could do it in degrees also and get the same result. So that's setting it up as a proportion. That's doing it without the formula. Now let's do it with our nice formula. Area equals 1/2 r squared theta. Right? We've already converted theta to radians. So the area equals 1/2 r squared, so that's 4 times 5/18 pi, which gives me 2 times 5/18 pi. 1/2 of 4 is 2. That gives me 10/18 pi, which is 5/9 pi feet. Oh, this is area, so it should be feet squared, sorry. Feet squared. Area is always going to be squared.
Why didn't the 2 go through everything? Just only the 5.
Say it again?
Why didn't the 2 go through like the 18 and the 5?
Because when we multiply fractions, we only multiply the top and then the bottom. It's 2/1, right? Remember, area is always squared. Volume is cubed. Okay. Okay, let's look at this example, finding the distance between two cities. Memphis, Tennessee is located 35 degrees 9 minutes north latitude of, and New Orleans, Louisiana is located 29 degrees 54 minutes north latitude. Assuming that the radius of the earth is 3,960 miles and the cities lie along the same longitude, find the distance between the two cities, right? So basically, okay, oops, it's a really bad circle. Right? So what we're saying is that our cities are located along, let me just do it over here, along the same longitude, right? So we're looking at something like this, okay? It's a pretty crude drawing, but that's basically what we're talking about, the curvature of the earth, right? So if I were to expand that, we're looking at this type of thing. I've got two cities located like that. Okay. Okay. So let's see here. We'll say that this is New Orleans. And this is Memphis. Right. Says the radius of the earth is 3,960. What does that matter? And that's this value right here, right? 3,960 feet right there, okay? I need to figure out this angle in order to find S. This is S right here, the distance between the two cities. So I need to figure out that angle. So theta is going to be, I'm going to do 35 degrees 9 minutes minus 29 degrees 57 minutes. Okay. So first, let's go ahead and convert those to just degrees. Am I going too fast? Okay, so we're going to convert them to degrees, and I'm going to just use my calculator to save time. If I can pull it up here. Oops. Okay, so we're looking at 35 degrees, right? So we go into angle. 35 degrees, 9 minutes. And let me just make sure I'm in degree mode. I am. Okay, minus 29 degrees, 57 minutes. You guys should be doing this with me, not just watching me do it. Doing it on your calculator. I don't know what happened. Should be doing it on your calculator, everybody. Okay. I get 5.2 degrees. Okay, so let me just talk through what we're doing here. Okay, my drawing is pretty bad. I'm going to try and draw that a little bit better while you guys get your calculators up. I want you to do that on your calculator by yourself. Make sure you can do it. See if I can do a better drawing here. I can draw really good circles on the board. Okay, so let's pretend that this is our equator, right? The equator goes straight across the middle there, right? So that's our equator. So then we're going to say, okay, here's New Orleans, and here's Memphis. Okay, this is 3,960 miles. I need to know the angle right here, okay? Now, when it says that Memphis is located 35 degrees, 9 minutes north latitude, that means that the angle from the equator is going to be 35 degrees, 9 minutes. So that bigger one is 35 degrees, 9 minutes. And then New Orleans is 29 degrees, 57 minutes. So that's the measurement from the equator. So in order to find theta, I have to subtract those two. Okay, does everybody understand that? That tells me that angle of theta. So this came out to be, what was it? 5.2 degrees. But we know our formula, S equals R theta. Theta has to be in radians. So now I'm going to take this 5.2 degrees and I'm going to multiply it by pi over 180, right? So I'm going to do 5.2 divided by 180 times pi. And this comes out to be 0.091 radians. Okay, I'm rounding it. Okay. So we got our radians. So now find the distance between them. So what am I looking for? Which is S. S equals the radius. What radius am I using? There you go. 3,960 feet times 0.091. Okay, and I get approximately 360.36. What's the unit? Miles. Okay. That's about how far apart they are. Okay, so we took We took their location, their degrees from the equator. We subtracted that in order to get this angle measurement right here. Okay, then we converted that to radians. And then we just used our formula, S equals R theta. Okay. Questions? Okay, so go ahead. I'm going to give you time to work on that worksheet in your Google Classroom. You're just going to do numbers 1 through 8. Okay, 1 through 8. Okay, so number 1, right, we're using the formula. It said to round it to 3 decimal places. That means we're not leaving it with pi in our answer, right? If it says to round it to decimal places, we're not leaving it with pi, okay? If it asked for the exact value, we would leave it with pi in the answer, okay? All right, so we've got S equals R theta. We're solving for theta, so we have S over R. So we're looking at 3 over 5 equals theta. So theta equals 0.6 radians. Okay, it said 3 decimal places, so theta equals 0.600 radians. It doesn't say anything about whether it wants it in degrees or not, so we can just leave it like that. Okay. Number 2, we're looking for R. S equals R theta, so S over theta equals R. So we're looking at 6 over, okay, 1/2, that's going to be a radians, right? It says radians, so 6 over 1/2 equals R. When we have a fraction in the denominator, we flip and multiply. So this is 6 times 2, so we get 12.000 feet. Yes.
We have to put 3 zeros after.
Well, yes, because it says to round to 3 decimal places. So
Even
that,
if it's a number, like it's even. Do it anyway.
yeah, if it says, yeah. Okay. Okay, looking for S. S equals R theta. So we have R, but theta is in degrees, so I have to convert it to radians. Right, 120 degrees times pi over 180. Let's say that's 12 over 18 pi, or 2 over 3 pi. So this is going to be, oops. Okay, so this is going to be 3 times 2 over 3 pi, which is, oops, which is 2 pi. Okay, this is an arc length, so I don't want to leave it as 2 pi because that sounds like an angle. This is an actual length. So I'm going to do 2 times pi, oops, which is 6.283 inches. Okay. Okay.
That's half a foot.
All right, next one. We're looking for R again. So S equals R theta. So S over theta equals R. We're already in radians. So we're looking at 2 over 1/3, which is 6.000 meters. Okay. I expect that you should have been able to do those pretty quickly and easily in pre-calculus. Okay. Okay. Find the length S and area A Round to 3 decimal places. Okay, what's the formula for area?
1/2
Theta. And S equals R theta. Okay, so let's see here. We have R, so we can easily find S. S equals 2, and this is in radians, so 2 pi over 3. So we get 4 pi over 3. So let's see here. Again, we're rounding to 3 decimal places. So that means we're going to multiply this out. So I get S is approximately 4.189. And what's the unit? Feet. Okay. So now let's look at area. Yes.
It would be feet squared.
No, because it's just, we're not, this is not the area. This is just the arc length. So we're just talking about that length there. Okay. Area equals 1/2 R, which is, R squared, which is 4, times theta, 2 pi over 3. Now this one just coincidentally comes out to the same thing, and it is just a coincidence. So this is going to be 4.189. This time it's feet squared. Okay. Okay, number 6. The location of this pi over 6 is a little confusing. That's actually referring to this angle here. I don't like the way they did that. Obviously, it's just because they couldn't fit the pi over 6 there, but it makes it look like this is pi over 6. But that doesn't make sense to be pi over 6 because pi over 6 is 30 degrees. So it doesn't make sense that this would be the pi over 6. So the location of that pi over 6 is a little weird. Okay, so let's see. S equals R, which is 3 times theta, pi over 6. So we're looking at pi over 2. Okay, and pi over 2 is 1.571. So S is approximately 1.571 meters. Okay. Okay, bless you. The area, 1/2 R squared, so that's 9, times theta, so pi over 6. Okay. So we're going to do 1/2, 9 divided by 6, times pi. And I got 2.356 meters squared. Okay. Make sure you put that pi over 6 in parentheses. Okay. Question so far?
Go get a question. What?
What's the question?
I saw approximately.
Oh,
I think that was a comment.
thank you.
That's a point off.
It is. Well, we don't want to be perfect because then you've got no room for improvement.
No, we like to be perfect.
Okay. A strawberry farmer needs to water a strawberry patch of 1,500 square yards that is in the shape of a sector of a circle with a radius of 40 yards. Through what angle should the sprinkler rotate? You know, I remember sitting at the dining room table with my dad, figuring a problem like this out when I was in high school because we had a blueberry farm and he had just put new sprinklers and irrigation pipes in and he was trying to figure out what angle to rotate it through. And we actually did this, believe it or not, just to figure out what area should be covered. Okay, so
I think I'll just
we've got a watermelon patch, a strawberry patch is 1,500 square yards. It's in the shape of a sector of a circle. Okay.
Okay.
All right. The radius is 40 yards. Through what angle should the sprinkler rotate? Okay. Any idea how we're going to figure out this angle right here? What's the 1,500 square yards refer to?
The area.
The area, right. And what's your clue that that's the area?
Square.
Square yards. That's my area, yes. Okay. And then we've got R. Question?
Couldn't we just do like the formula but backwards?
The formula what?
But backwards.
What formula?
The area.
Well, yeah. We didn't get there yet. Yes, very good. Okay, so we've got area equals 1/2 R squared theta. So we're looking for theta. So we've got 1,500 equals 1/2 40 squared times theta. All right, so remember we do the 40 squared first. 1/2 40 squared is 1,600. 1/2 is 1,600. 800. So theta equals 1,500 over 800. So theta equals 15 over 8. Did I do that right? Yes, and this is radians. Right? That's not going to help you when you're watering your strawberry patch, so we need to convert that to degrees. So we're going to do theta equals, how do we convert that to degrees? Times 180 over pi, yes. All right, so use your parentheses. 15 divided by 8 times 180. I have 18, sorry about that. 180 divided by pi. And that gives me, what in the world is going on here? Thank you very much. Right, theta is approximately 107.42958. So that's going to be 430 degrees. Does it say what to round this to in this section? Doesn't change, so we're just going to keep going with the same thing. Okay. Are we good? Okay, so for homework, do number 8.